Alrighty, I'm back. This is Mr. Steele, here to this time go through graphing a cosecant and then a secant function. So the reason I'm doing it right now instead of waiting till we actually teach it in class is because my voice is going really badly. I don't know if anyone noticed that today, that I was feeling a little under the weather, but my voice could go at any time, so I figured it's better to do it now. Plus, it's really a lot of fun for me to graph cosecant and secant functions. So that's my goal here, is we want to graph a completely involved, a little bit of everything kind of cosecant function, then we'll do a secant one, then we'll call it a night. So first, over on the right side, I've got for reference the graphing Cosecant Tanifesto, and of course there's only 4 steps here because it really just relies on the graphing manifesto, because our first and second steps rely on us being able to graph cosine or sine. So that's where we're going to start, is we'll graph the reciprocal function, sine or cosine. In this case, since it's cosecant, it'll be sine. We'll do it the skeleton style, so I'll use different colors here to make that clear. Then I'll reciprocalize it, so we'll take advantage of the fact that when you take 1 over a function, zeros become vertical asymptotes, and then we're going to turn our maxes and mins into the corresponding piece by the same token, and then of course I get the coolest shape ever. So hopefully I'll be able to do a comic book guy impression. Alrighty, so let's actually get started here. So we're graphing a cosecant function. So where we're going to start is with the first step. So we're going to pretend we have a sine or a cosine function. So to do that, I'm going to try and do all of it in blue. Most of our analysis is actually going to come from that sine or cosine function. So in this case, what I'm going to pretend is that we're looking at instead 4 minus 3 sine of 2x minus 4 pi. And again, the reason why is because cosecant of x equals 1 over sine of x. They're reciprocal functions. So we're going to use that information to kind of build up our skeleton, and then we'll actually graph the cosecant on there. So in order to do this, let's do the analysis for the cosine, or for the sine. So I'm going to start with the period. So I always like starting there. My period in this case, it's 2 pi. Since we're talking, it has to do with sine, so we're going back to 2 pi, not like tangent. 2 pi over the coefficient of x, so it'll be 2 pi over 2, which equals pi, which is kind of nice. Of course, that means that my half period, if I'm going to find that, is going to be half of pi, which is pi over 2. So there's my half period. Next, I want to find my amplitude. So now the amplitude isn't quite the same thing as it is before. It's really just kind of shifting where our maxes and mins are, but because I can't think of a better word right now, I'm going to use amplitude, or I might call it like a vertical stretching. Maybe that's a good word. Vertical stretch. I think that's a good enough word. My vertical stretch, same thing as before, it's going to be the number that's actually touching the trig function. So in this case, it's going to be the absolute value of negative 3, which is 3. So there's nothing really changed there. After amplitude, we've got to find our vertical shift and phase shift. My phase shift, I'm going to have to actually do some work this time. So it's setting my argument. So the thing inside the function right here, equal to 0. Well, when I actually solve it, I'm going to get, sorry, let me put an underline over there. I'm going to get 2x equals 4 pi, or dividing by 2. I'm going to get that x equals 2 pi. So my phase shift is going to be 2 pi, which is interesting, but we're not going to actually think about that. So there's my phase shift. Then last, my vertical shift. I can find that right here, looking for the number, the constant away from it. It's going to be just that, positive 4. So plus 4 or up 4. Okay, so, excuse me, we've got the general information here about the reciprocal function. So when we skeleton graph it, we just really carefully kind of put it on the graph so we have it there. So this isn't going to be actually part of our graph, so I'm going to use a different color. I'm going to keep it in blue for this case. I'm going to make it kind of dotted instead. Now, obviously, when you're graphing it, if you use a pencil, you can just erase your pencil marking. I think you know how to actually erase, so just ignore that. But again, our real shape isn't going to come just yet. So starting with my thing, we're graphing a sine function. So we're graphing the reciprocal, so sine. And so sine starts in the center. And then since it's a negative 3 cosecant, that's a negative sine, so we're going to go down. So again, I'm going to use dot dot dots. And notice I'm not going all the way up to the top here, because I'm going to actually need some of that space for graphing the actual cosecant. So now I'll do the same thing over here. Okay, so those aren't actual points on our graph, but I'm doing it just so I can kind of see it. And so there is the skeleton graph of my sine, the reciprocal of cosecant. Now obviously though, since we're here, we might as well label all this stuff. I mean, get all those pieces of information down. So I'm going to give myself room here. So first, let's see, the easiest part, probably my vertical shift is the easiest. So it was a +4, so y equals +4. And then this point and this point will then be 4 plus my amplitude, so 4 plus 3 is going to be 7. And then 4 minus my amplitude, so 4 minus 3 is 1. So that's kind of nice. That tells me that if 1's right there, my x-axis is probably somewhere around here. And so this picture could get a little confusing with trying to think of the best way to do this. I'm going to leave it that way. This is my x-axis. So I want it on there. And so now we just get a little better picture of what it is. So this graph will be kind of shifted above that point. Okay, next, let's take care of the horizontal shifting. So our phase shift is 2 pi. So x equals 2 pi. So that's perfectly cool. And so now for labeling my far off distance, it's got to be my phase shift plus my period. So phase shift is 2 pi plus a period of pi is going to be 3 pi. And over here, 2 pi minus a phase shift, 2 pi minus pi is going to be just pi. So now in this case we aren't actually going to see our x-axis here, or our y-axis. It's going to be somewhere over here. So I'm not going to worry about it. It's too far out of the picture. We're not going to see it if we graph this on the calculator to check it. So I'm good right there. Okay, finally, before we can really get to the actual cosecant shape, we want to make sure we've labeled the half periods too, so we have a little bit more context for what we're looking at. So to label those guys, I'm going to add my phase shift plus my half period. So there's my half period. And so that's going to mean I'm going to be doing 2 pi plus pi over 2 for this guy, and then 2 pi minus over there. Well, to do these, I've got to get a common denominator. So both over 2. It's going to be 4 pi plus pi equals 5 pi over 2. So 5 pi over 2 is right there. And then over on the other side, if I subtract it, 4 pi over 2 minus pi over 2 is going to be 3 pi over 2. So right here is 3 pi over 2. So yay, we're halfway there. So we've got the reciprocal function skeleton graphed. So with those little dots, we've got the bones. Ooh. Now though, we want to actually graph the real thing. We want to get that. So we're going to take advantage of what reciprocal functions do. So we did this is in the past before I've actually taught it. So in the future, we will pay attention in the beginning to the fact that, when a function has a 0, its reciprocal has a vertical asymptote. So the place we're going to start is we're going to make all the zeros vertical asymptotes. So I'm going to a different color because now my pink pen is going to represent my actual cosecant function. So I'm drawing these guys up here. Okay, so now that does have one in the center on the phase shift. So to make it clear, I'm actually kind of graphing it a little off to the side. That's just me making sure it looks right. This gets really exciting right near the end. Okay, so they're all my vertical asymptotes. So some of them are labeled. Actually, all of them are labeled, aren't they? Got one at pi, 3 pi over 2, 2 pi, 5 pi over 2, and 3 pi. So that's kind of cool. Now that we want to actually graph the thing. So first we're going to dot the maxes and mins. So basically, when you take a reciprocal, the biggest values become the smallest, and the smallest values become the biggest. So our mins are going to become relative maxes. So I can dot both of those. Then these guys are going to become relative minimums because they were relative maximums before. And so now we're kind of set up. We've done everything. So now it's time to enter the comic book guy. Best shape ever. So here we go. Hope that was an okay impression. Haven't done comic book guy before. So what we're going to do is we get to make those little mini parabolas. It just sounds like fun. So we kind of go in here. Now they're not really parabolas, but the shape kind of reminds me of a parabola. So kind of hug the asymptotes just like it would on a rational function. And okay, so my graph's a little spread thin, but there it is. The pink graph actually represents our cosecant function. So at this point, all we're left to do is actually check and see if we got it right. So let's do that with a calculator. Okay, time to bring on the TI-83. So there's my gigantic weird one. So here it started. Let me just make sure it's working. It's not working. Let me reset it. Reset calculator. Memory's cleared. Good. So let's go graph. So I want to punch in this function. So it's not going to be easy to punch it in if we're not careful here, because there's not a cosecant button. Like, I can't just go down and go, oh, there's the cosecant button. Let me just push the cosecant button. So I need to actually type this in correctly. So 4 minus 3. Now, because it's cosecant, we're going to have to use the reciprocal fact. So it's going to be divided by the sine of 2x minus 4 pi. And so there is my function typed in correctly. So I'm using the fact that sine or cosecant is 1 over sine. Now I've got to go to my window. Let's go to my window. I've got to punch in what I see. So it's starting at pi. It's going up to 3 pi. So I'm just punching them straight in as they are. For my scale, I could just kind of guess. I think it's probably pi over 2. Like, again, there's no real reason to change this. I just like kind of making it match what I see, and I kind of see pi, like 1 pi, 1.5 pi, 2 pi, 2.5 pi, 3 pi. So I'm just gonna go that way. Now for my maxes and mins, if I put just -1 and 7, like I wouldn't actually see the graph. Like, that would only go like this stuff. Like, it'd only give me the middle piece. So I'm gonna actually make it slightly bigger. I'm gonna go from, I don't know, let's go from -5, maybe? I don't know, -5? Oh, go to. So, I typed in a minus sign when I should have put a negative sign. So -5. Then let's go up to 12. Just kind of making numbers up here. So I'm just trying to be bigger than my -1 and 7. And so now when I graph it, hopefully we get the same shape. Obviously the calculator's a little limited. Oh, that's awesome. This is awesome. That could not have been better. That's fantastic. Now the only difference is obviously on my calculator screen up here. I got a little more than over here, but that's pretty awesome. Like, I mean, all I can really say here is best trig function ever. So, yeah. There we go. Cosecant's graphed. Let's do a secant.